What if we could tell you everything? The entire history of the world. Now, what if we told you we could do it in just 2 hours? We're going to tell the whole story, from the Big Bang to the present day. How the planet prepared for the rise of man. How the Stone Age led to the steam engine. How the first seeds sprouted into cities and civilizations. Everything is connected, and the path leads to you. It took history 13.7 billion years to unfold. We'll show you everything you need to know in the next 2 hours. This is our infant universe. Everything that will ever exist, everything that will ever happen, all begins here, within this tiny bundle of energy, smaller than an atom. And right now, history as we know it is about to mysteriously begin. For reasons we may never know, our universe suddenly erupts.
In a millionth of 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 a second, it went from a size smaller than an atom to bigger than a galaxy. Whoosh.
What you're seeing is energy, and it's one key to understanding everything that will unfold in the next 2 hours. Within a fraction of a second, the Big Bang creates all the energy that will ever exist. All the energy that will power the stars, that will fuel anything that ever lives. All the energy that you will ever consume dates back to the beginning of time.
When you put gas into your car, you're tapping energy that was created during the Big Bang. You're tapping the energy of the universe itself.
We're only a few minutes into our 2-hour journey, but already 380,000 years have passed. You are about to witness the birth of your original ancestors, the first atoms. This is hydrogen. The universe will use it to make everything in the world around us.
Hydrogen is like a baseball team. You say, what player do I want to start my team with? Well, if I want to start a universe, I want to start it with hydrogen. Because from that, with a lot of heat and a lot of pressure, you can build more kinds of atoms.
The first atoms blast through the early universe. And luckily for us, they don't spread out evenly. Because in those tiny pockets with more atoms, gravity, the great sculptor of the early universe, begins to work its magic. The first galaxies are beginning to form, revealing a timeless secret of the universe. Throughout history, whenever more matter and energy can be drawn together in one place, more complex things can emerge.
We have all of these urban centers around the planet where so much creativity, so much art, so much science, so much culture came about because of all these opportunities for things to interact with each other.
Really, in a sense, where there is stuff, new stuff can develop, and where there isn't anything, nothing much can develop.
300 million years after the Big Bang. Inside of forming galaxies, gravity continues to squeeze together clouds of gas and dust, causing pressure and heat to violently rise. When the temperature reaches 18 million degrees Fahrenheit, hydrogen atoms slam together, creating a new element, helium, and radiating bursts of energy. The first stars are born.
Suddenly, there were these new beacons of light shining forth, pouring energy into the universe. Let there be light.
But something is missing from this early universe. There are billions of stars, yet not a single planet. To form planets, and eventually people, to take the next leap that would make all of history possible, the universe needs more to work with than just hydrogen and helium.
The complicated elements, the heavier things that we build stuff out of, for example, iron or life built out of carbon and things like that, they're actually manufactured in stars.
We may see stars like our own sun as sources of light, but there is something bigger happening deep inside. Stars are element factories. They fuse hydrogen into helium, helium into lithium, forging 25 of the most common elements we'll need to live, including carbon, oxygen, nitrogen, and iron. So, more than 12 billion years ago, stars are already creating the element that will spur the Iron Age, allow for the building of cities, and the creation of some of mankind's most famous monuments. But a look at the Statue of Liberty reveals the next challenge awaiting the early universe. While the statue's frame is iron, her skin requires an element too heavy to be made in stars. For Lady Liberty to have material for her skin, for there to be gold for wedding rings, or uranium for nuclear reactors, some elements had to be created another way. Stars don't have enough energy to do the job. But if the element factory isn't powerful enough, how about blowing up the factory?
Just a few million years after the first stars formed, some of them exploded. Wham!
These explosions, known as supernovas, are the biggest blasts in the universe since the Big Bang, providing the extra boost of energy needed to fuse heavier elements. In the fiery blast of their own destruction, stars create uranium, gold, all the rest of the elements that will fill our world, including copper.
The periodic table of the elements is really sort of a library of matter in the universe. Those are your building blocks. Everything is coming out of that particular chemistry set. Supernovas are absolutely necessary for us to be here. You know, we have iron in our blood. We have little bits of old supernova, therefore, just floating around through us. We are all stardust.
Copper and tin, Bronze Age. Without supernovas, there's no Bronze Age. Go to any supermarket and buy a multivitamin. And go and look in the ingredients. You'll find copper, you'll find zinc, you'll find selenium, you'll find all sorts of elements that can only be made in a supernova.
The elements made by stars will become the seeds of life on Earth and the drivers of human history. But the journey has just begun. Before there can be life, the universe has to build us a suitable home. To build a proper house, you have to assemble the right materials all in one place.
Now, when planets form, it's the same thing. It's the materials that you have at hand that's going to dictate the kind of house that your planet's going to be.
To get enough of the right material in the right place, all at once, takes a very long time. Over the next 8 billion years, more than half of history as we know it, the element factories continue their work. Stars explode and are reborn. Each generation with more heavy elements than the last. Until 4.6 billion years ago. Finally, there are enough materials gathered for the next step on the path to us. A new star is born. This is our sun. It's so massive that it's gathered up 99.9% of the gas and dust in the solar system. But there's still just enough left behind for gravity to build some other things. Like planets. The third one out from this star will be our home. By the time Earth emerges, just over 4.5 billion years ago, 2/3 of the history of the universe has already passed. The first sunrises sweep across a foreboding alien planet. A world spinning so rapidly that a day lasts only 6 hours.
When you go back to the early Earth, right after the planet formed, you really have to think of the Earth as another planet. The sun would have looked out over a hellacious scene of just molten lava. In places, you would see rafts of black volcanic rock.
Within the liquefied rock, the elements are all in a jumble. Something has to bring order out of this chaos. And once again, that something is gravity. Lighter material drifts toward the surface and forms a solid crust, while heavier material sinks toward the center, forming a molten iron-nickel core. This churning liquid metal creates a magnetic field that reaches out into space. Like a force field, it will protect our future home from the sun's deadly charged particles. Soon, this magnetic field will allow for life to grow, and later, guide the explorers who will connect two halves of the world. But for all this to unfold, the Earth will need a critical partner. $4.5 billion years ago, an object the size of Mars smashes into the planet at 25,000 miles per hour. Earth swallows up much of the impactor. But a spray of molten debris is whipped off into space. Within as little as a year, gravity gathers this debris into a secondary sphere in orbit around the Earth, where it has been ever since.
The formation of the moon was an incredibly important event in Earth's history.